So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to discuss a lecture about importance of physical geology. So in the previous lecture, we have just discussed about different kinds of construction failures and types of weathering process and what is the importance of geology in the civil engineering point of view. So today we'll be discussing about the importance of physical geology. What is physical geology? So physical geology is also part of geology where we study about the different kinds of earth material. So this we'll be discussing today in this lecture. So let us start with the first information about it, the introduction about physical geology. So what is a physical geology? Physical geology is essential because it provides a fundamental understanding of earth materials. It provides an understanding of earth materials, processes, and its history. So because it gives you the information about the earth materials and the physical features which are present on the earth surface and how they process and how what is the history about it, from how many years it was formed, what is the formation process, what is the type of cycle it has gone through. That all information we study in this physical geology. And here there are some reasons why it is important to study. So we have some key reasons here, like first of all, understanding the earth materials. What is earth material? So earth material is related to the physical geology, the materials which is on the earth surface, like in the form of rock, minerals, and soils. It is in the form of either rocks, either minerals, either soils. So these minerals, these materials, we study it for the information about the geological patterns, their processes, and the formations and all. So it identifies the understanding the earth materials means identifies the different types of rocks, minerals, and soils, and helps in assessing the strength and suitability of the materials of construction and engineering projects. So it will help us to assess the strength, it will help us to assess the suitability of the materials for the construction projects and for the engineering projects. Now, the materials which we find it from the earth materials, so these are like minerals. What are minerals here? So minerals, let us define mineral first of all. Mineral is a naturally occurring inorganic substance. So it's a naturally occurring inorganic substance with a definite chemical composition, and a crystalline structure. The mineral process is like it is a natural occurring phenomena and it occurs naturally in the environment, and it is having a definite composition and a crystalline structure. So importance of the mineral, if we see here, so it serves as a building blocks of rocks. So minerals will serve as a building blocks of rocks, and it is essential in the construction. Example, quartz in glass, feldspar in ceramics, and it is used in the industries, and iron ore for steel, bauxite, and for the aluminum process. So what are the examples here? So examples, if we see here, quartz, feldspar, calcite, mica, olivine. So these are the different examples where we can just consider under the minerals category. Now rocks here. So rocks are naturally occurring aggregates of minerals. They are classified into three types based on the their information. What are the igneous rocks formed from the cool? There are different kinds of rocks. We call it as igneous rocks, metamorphic rock, and sedimentary rocks. So if you talk about the igneous rocks, so these igneous rocks are formed by cooled magma or lava. So these are the two types of rocks which is formed by the igneous process. Either it is formed by the magma, either it is formed by the lava process. So in this we have intrusive and extrusive kind of formation. So when you talk about intrusive, we call it as plutonic rock, and it is formed inside the earth surface with a slow cooling, like a process under the earth surface. It goes on with a slow cooling process. And the examples here is granite and diorite. So here, like suppose the lava comes out of the volcano. If suppose this is the volcano, so this is the lava which is inside the volcano. We call it as lava. So here we have the molten material. We call it as molten material, We call it as magma. Okay, magma. So this magma, so when it cools here itself, when it goes to the nearby beds and it cools inside itself, that we call it as intrusive rocks. Okay, so with this kind of rocks, once the magma cools down, very slow process, so these kind of rocks we find it as a granite and diorite. So these are the few of the examples of the intrusive rock. When you talk about the extrusive rock is volcanic rock, we can even say. So this is formed on the earth surface with fast cooling, for example, basalt and pumice. So this lava, when it comes out and it comes in the contact with the air, okay, contact with the air, then what happens? It cools very fastly, and after cooling down, it forms the igneous rocks. So what are the examples here we see here? Basalt and pumice. So what is the importance here? Used in the construction, granite for buildings, basalt for roads. So these are the different importance of these kind of rocks. Now, if you talk about the sedimentary rocks are formed by the deposition and compaction. Deposition and compaction. So here we have clastic, chemical, organic importance. So what is the clastic here? Made from rock fragments like sandstone and shale. Chemical is precipitated from the solution like limestone rock and salt. Now organic formed from the plant element remains or coal or chalk. So here importance here is, what is the main importance of the sedimentary rock here is reservoirs for oil, gas, groundwater used in the cement production. So sedimentary rocks, these are the formed by the composition or compaction or deposition process. Like all the sediments, they will just come together and form they'll compact to each other and they'll form a rock. So that kind of rock we call it a sedimentary rock. Now we have a metamorphic rocks. So metamorphic rock is a rock which is it formed under the heat and pressure when the igneous rocks or sedimentary rocks goes through the metamorphism, that we call it as formed under the heat and pressure conditions when it changes properties. So that kind of rock we call it as the metamorphic rock. Now foliated layered appearance, like example slate, schist. Non-foliated, no layering, example marble, quartzite. Importance is used for construction or for the decorative purposes. Now here, what are the types here? If we see the types here, metamorphic rocks. Now types is sand, silt, or clay or loam. So this all comes under this soil conditions. Now when you talk about soil, so definition of soil is loose surface material formed by the rock weathering, and composition is mineral, organic matter, water and air. So what is the definition of soil here is, soil is a loose surface material which is formed by the rock weathering. So we have seen the three different types of rocks here, that is igneous rocks, metamorphic rocks, sedimentary rock. So when the weathering process takes off, then what happens? The loose materials which is formed by the weathering of rock, that is called as soil. So we have different kinds of soil here. Sandy soil, we have coarse drain kind of soils, silt kind of soil, medium sized particle retains some moisture, and clay kind of soil is fine particles, holds water and sticky when wet. So we have loam and bleach mixed sand, also silt clay, and best for the agriculture purpose. So loamy soil is the best for the agriculture purpose, which we find under the soil types. We have a sand kind of soil, silt kind of soil, clay kind of soil, and loamy kind of soil. So what is the importance here is supports the plant life, construction foundation, water filtration process. Now what is water as an earth material? So this also comes under the earth material conditions. So water as an earth material. Why we call it as water as an earth material? Let us understand first of all. So it covers 71% of the earth's surface. So as the water covers 71% of the earth's surface, okay. So in the form of oceans, in the form of lakes, in the form of rivers, in the form of groundwater. So these are all types of forms which is present on the earth's surface, as we call it as 71% of the water body. It is present on the earth's surface. Now the water which is essential for weathering, erosion, sediment, transport, and affects the soil stability, rock weathering, and landform development. So this is very much essential for the weathering process, very much essential for the erosion process and the sediment transport, and which affects the soil stability, rock weathering, and the landform development. Now water is considered as a earth material. Why we call it as water? It is considered as earth material because it is naturally occurring substance that plays a crucial role in the earth geological and environmental system. It interacts with minerals, rocks, soil, influencing landscape ecosystems. And here are some functions as the earth material. So how does the water work as a function as a water earth material? How we know? First of all, role in weathering and erosion. So water acts in weathering, acts in the erosion process, where water is a major agent for both mechanical and chemical weathering process. So when a weathering process occurs, so water is the main source for the chemical weathering as well as for the mechanical weathering process. So when the rock comes in the contact of the water, this chemical and mechanical weathering process takes on. So mechanical weathering, water seeps into the rocks, cracks, freezes, and expands the breaking and rock apart. Freeze and thaw action is acting on it. So where the it's when the water seeps into the rocks or in the cracks or when it expands and when it breaks down, that kind of weathering we call it as the mechanical weathering. Now, what is chemical weathering? Where the water dissolves minerals and reacts with the atmospheric gases. For example, carbonic and acid formation, altering rock composition. So this is how the water acts as a earth material. Now, when you talk about sediment and transport deposition. Now here rivers, streams, and oceans. Rivers, streams, and oceans. They currents, ocean currents transports the sediments and shaping landforms like deltas, floodplains, and beaches. They will form the landforms by this kind of deposition process, and water-driven erosion carves out valley and canons over the time. Now, water in the rock cycle. So, when you talk about rock cycle, water works as a very important agent here. Now, water plays a key role in the formation of the sedimentary rocks. It plays a very important, very key role in the sedimentary rock process as it transports the deposit sediments. In the metamorphic rocks process, water facilitates mineral transformations at high pressure and temperature. Now, groundwater and soil interaction. Water moves through soil rocks layers, affecting the soil stability, permeability, porosity. So, water moves through the soil. First of all, whenever the water moves through the soil layers, it affects the soil stability. First of all, affects the permeability and the porosity of the soil. Groundwater is stored in the aquifers and can dissolve minerals, leading to the features like caves and sinkholes. Now, water and plate tectonics. Water reduces the melting point of rocks. It reduces the melting point of rocks, aiding in the magma formation. Subducted oceanic plates carry water into the mantle, influencing the volcanism and even the seismic activities. Now, water is a geologic agent. So, how the water works as a geologic agent also? Like glaciers, frozen water shape the landscapes by carving the valleys and the depositing sediments. An ocean regulates the earth climate weather patterns, impacting the erosion and the sediment distribution. Now here, this is how the water acts as a earth material because it is involved in the erosion process, involved in the weathering process, involved in the geological as a geological agent, involved in the rock cycle, water cycle. This is how we call it as water as a earth material. Now let us understand the second point here. So that is the natural hazard and mitigation. Natural hazard and mitigation. So in the physical geology, we studied about the natural hazard and mitigation. It helps to predict and manage the earthquakes, landslides, volcanoes, and the floods. Aids in designing structures resistant to the geological hazards. It is resistant to the geological hazards. Now, types of natural hazards here and mitigation strategies. We have earthquakes and what are the earthquakes here? What is the main cause of earthquakes? Earthquake is the movement or shaking of the ground due to the tectonic plate activities. So, movement of tectonic plates along with the faults, release of energy from the earth crust. So, these are the cause of earthquake. Now, what are the mitigation strategies here? So, seismic resistant construction you have to make, seismic resistant construction building. So, use flexible materials, base isolators, and reinforced structures and building codes and regulations, enforce the earthquake resistant design standards, land use planning, avoid construction in high risk seismic zones, and early warning systems detect the seismic activity and provide the alerts. So these are the different mitigation measures we can take when this earthquake occurs. Next comes to the landslide. What is a landslide here? So causes heavy rainfall, earthquakes, deforestation, and weak rock formation. So main cause of landslides here is heavy rainfall occurs, occurs, deforestation occurs, weak rock formation occurs. Now, what is the mitigation strategies for this? So the mitigation strategies for these are slope stabilization. So here retaining walls used to prevent soil erosion, rock bolts, anchor bolts and stabilize rock, geotextiles, permeable fabric used to separate, filter, reinforce and then drain the soil. Now vegetation and deforestation, planting trees to stabilize the soil and proper drainage system, redirect water flow to prevent the erosion, monitoring and early warning, use sensors and satellite data to predict the movement of the uh, this landslides. So these are the different kinds of mitigation measures we can take whenever this landslide occurs. First thing is slope stabilization we can do. Second thing is vegetation and reforestation we can do, because vegetation and reforestation will just stabilize the soil. It will help in the soil erosion. So soil erosion will not take place and the stability of the soil will remain as it is. So this is the way of mitigating the landslides wherever this kind of landslides occur due to heavy rainfall or deforestation process. Now talking about floods. What is a flood here? So flood means it causes through the heavy rainfall or river overflow, storm surges and poor drainage. So these are the different causes of floods. Either it can occur through heavy rainfall, it can occur through the river overflow, or through the storm surges, or through the poor drainage systems. Now, what is the mitigation process here? Mitigation strategies we can use it here is flood control structures. We can just make the flood control structures like dams, levees, and embankments. We can make it for the reduction of the floods, or we can control the floods over it. Now, urban drainage improvements. Urban drainage improvements is we can just construct proper drainage channels, zoning land use policies like restrict the construction in the flood prone areas, rainwater harvesting and watershed management, reduce the surface runoff. So this is how the mitigation strategies we can use. And the D is volcanic eruption. So how does the volcanic eruption occurs? As I told in the previous slide also, in a volcanic eruption, there is a molten material, we call it as magma. So when this magma comes in the form of lava, when it comes out, then we call it as volcanic eruption. So magma movement and gas built up beneath the earth's surface. Now, mitigation strategies, if we talk about mitigation strategies, volcanic monitoring, use seismic activity detectors and satellite imaging, execution, evacuation planning. Evacuation planning can be done in the mitigation methods, like establish the safe zones and the emergency routes. We can just plan it for evacuate at the time of the volcanic eruption, and continuous monitoring can be done. Public awareness and education. Train communities on the volcanic hazards. We can just go with the training to the communities with the volcanic hazards. Structural production build barriers to redirect the lava flow. So we can build the different barriers to redirect the lava flow. This is how we can just monitor and try to avoid the losses in the when we study this physical geology. Now tsunamis. Tsunamis are the one more different disaster in the history, like causes under the water, earthquake and volcanic eruptions or landslides. These are the different causes for this tsunamis. Now, what are the mitigation strategies we can just study about this? Tsunami early warning systems. Detect the seismic activity and issue alerts. It will just detect the seismic activity and the issue alerts. Coastal defenses, build the seawalls, mangroves, forests, and artificial reefs. Evacuation plans we can do, develop and practice the tsunami drills. Land use planning can be done or restrict the development in the high risk coastal areas. Now, next thing, what we can see here is resource exploration and the management. So, essential for locating the extracting minerals, oil, gas, and groundwater promotes sustainable use and natural resources. Now, in this, we have resource exploration. We have types of natural resources like mineral resources here. So, metals, iron, copper, and we have energy resources like coal, oil, natural gas, uranium, geothermal, solar, and wind. And in the water resources, we have groundwater, surface water, ocean. Biological resources, we have forest, fisheries, and the agricultural lands. What are the exploration techniques? We talk about resources. What are the exploration techniques here? Geological surveys we can do, mapping the rock formations and the mineral deposits. We can use the with the help of the surveys we can just find out and we can prepare the maps for the different kinds of rock and mineral deposits. Now, geophysical methods. Using the seismic and magnetic and gravity surveys, we can just use the seismic activity uh, methods and the magnetic methods and the gravity methods for the surveying process. Geochemical analysis, testing soil, water, rock samples for the mineral content, and remote sensing and GIS. This is one more new technology. We can use it for the satellite, and in this process, satellite images for the resource identification. We can just find out the uh, same area satellite images or concerned area satellite images to find the resource identification digitally we can do. So now drilling and sampling, so core drilling to confirm the resource availability. Now when you talk with the fourth point, that is about the environmental protection. What is environmental protection here? So environmental protection is assist in understanding the soil erosion, pollution, and land degradation. So it will tell you about the soil erosion, it will tell you about the pollution, it will tell you about the land degradation process, aids in development of sustainable and land use practices. What are the key environmental issues here is air pollution. Air pollution which causes by industrial emissions, vehicle exhaust, burning of the fossil fuels, and what are the effects here? If you see the effects here is respiratory diseases, climate change, acid rain. So these are the different kinds of effects of air pollution, which is caused by this environmental issues. So in this, the effects will be like respiratory diseases will occur, climate change will occur, and the acid rain will occur. That solutions, if we see, so use of renewable energy. We can use the renewable energy. We can use the renewable resources like solar or wind. Now, emission controls and air filters in industries, we can use the emission control methods or the air filters in the industry. Now, promotion of public transport, we can just promote the public transport and electric vehicles, which will just reduce the pollution in the air. Now, engineering and infrastructure development, when you talk about this point, engineering and infrastructure development, so crucial for site selection, foundation design for buildings, bridges and dams, and helps in understanding the soil and rock behavior under the load. Now, in this introduction, if you see the realm of infrastructure development, civil engineering plays a crucial role. It encompasses a wide range of disciplines and expertise that are essential for planning, design, construction, and maintenance of the various infrastructure projects. So we study about the roads and bridges and to the buildings, airports. Civil engineers are the driving force behind the creation of the safe and efficient and the sustainable structure that form the backbone of the modern society. So this article explores the significance of civil engineering in the infrastructure development, highlights the key aspects that make it indispensable in shaping the and build the environment. Now, the foundations of civil engineering here, the civil engineering has a rich history of dating back thousands of years back. So, ancient civilizations such as Egyptians and the Romans, they showcase their remarkable feats of engineering through the construction and the magnificent structures like the Great Pyramids and the aqueducts. And over time, the field has evolved and advanced, incorporating new technologies, materials, and construction methods. Now, water resource management, when you talk about water resource management, so it studies about the groundwater movement, availability, and helps in preventing the contamination, depletion of the water resource. It will help us to maintain the groundwater movement, its availability, its stability, and helps in preventing the contamination and depletion of the water sources. So, water resources management is international multidisciplinary forum for the publication of original contributions, and it exchanges the knowledge and experience on the management of water resources. And so, in the particular journal, publishes contributions on water resource management, assessment, development, and conservation control, and emphasizing the policies and the strategies. Now, contribution examine planning and design of water resource systems and operations, maintenance, and administration of the water resource systems. Next point, if you see about the climate change in the Earth history, so physical geology even tells you about the climate change activities which are taking place day by day, and the history of the Earth's surface, like how many million years ago, what was the condition of the Earth, what was the types of species present over there, in which era, what kind of condition was there. That all, when you study about the physical geology, we'll get to know. So provides the insight into the past climate changes through the rocks and fossils records, and helps to predict the future climate patterns based on the geological evidence. So whatever evidence we get, based on that, we can just predict the futures. Now, evidence of past climate change, ice cores. So ice cores, when you talk about ice cores, trapped air bubbles in the ice from Antarctica and in Greenland reveal the past atmospheric composition and temperature trends. So temperature trends. So sediment cores here, layers of sediments in lakes and oceans contain the fossilized pollen, microorganisms, chemical signatures indicating the past climates. Now, tree rings, when you talk about tree rings, so the width and the density of the tree rings reflect the temperature and the rainfall variations over the centuries. And fossil records, plants and animals fossils show how species adapted or went extinct due to the climate shifts and all. Now, glacial evidence here is moraines and stations or other glacial features indicate the periods in glaciations and warming. So these are all the information we will get to know in this climate change in Earth history. So this all we have to understand when you study about the physical geology. Basically, it will tell you about the all the Earth surface feature, about the resources, about the disasters, occurrence, about the Earth history, about the climate change activities. This all we will get to know, and understanding the Earth materials means we will get to know about the types of the rocks, types of the minerals, and types of the construction materials which are present on the Earth surface. As a civil engineer, we should understand this all as in the physical geology to go with a proper and successful construction. So just we should understand that what kind of rock, what kind of mineral it is, and what kind of activities will be present on the Earth surface feature, and what kind of earth materials we use it for the construction purpose. So this is about the importance of physical geology, and these are the few references you can just go through to find out the more content about it. So Keshavalu and Chenna, Venkat Reddy, these are all the textbooks where you can just go through and refer the books for finding out the more content about it. So that's all for today. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.